Good afternoon. A little more enthusiasm. Good afternoon. I'm Ben Parvey. I'm the CEO of Blue Sky Power. As Paul mentioned, we're the project developer for Simpson House's tri-generation project and integrated clean energy infrastructure project. Going straight into it, we did the project under what is referred to in the industry as FD Boom, or Finance, Design, Build, Own, Operate, and Maintain, meaning we bring a whole package solution together. A lot of times when people say turnkey, it doesn't necessarily include about 5 to 10 other things. It includes the construction. We did at-risk project development from the beginning of looking at what types of systems we can do and how we can finance them. Paul mentioned Steve Weber, who is the engineer who did all those studies, all the energy modeling, and pulled it together. Steve's over there and did an excellent job in pulling that together. In addition to that initial design, we also put together the finance structure, which I'll go into in further detail, as well as oversee the construction and the construction management. The ownership and operation through our partners at Centrica, and ongoing O&M. So this project we're talking about today is the Simpson House. We of course looked at the whole interior of the building initially at the Simpson House. Oh wait, that's not it. This Simpson House. All right. So in looking at the Simpson House, which, as Paul mentioned, is over 150 years old, their boiler room looks like it's 150 years old. It really was one of the most incredible things, this old stone structure with these old boilers in it and crumbling walls inside. But it's an amazing structure to work within, to see a facility that's this old. And we've dealt with 100-year-old facilities, facilities from the early 20th century, but for a facility like this, the history is incredible. And to do a project like this in the city of Philadelphia, was a real opportunity, and to work with our partners to get it done. So we had a holistic approach, which is what we do with all projects, which is to come in with no preconceived notion about what's going to happen there and what the solution is going to be. We always hope that there's a good distributed generation asset, sizable CHP or other project, given the lower cost natural gas and higher electric costs, as well as the incentives in the Commonwealth of Pennsylvania and other incentives through PICO and PGW. So we took a holistic approach. That's why, as Paul mentioned, not only is it a 265 kW tri-generation project, it also includes a whole lot of other things we'll get into in a minute. The basis, or the core of the project, the largest part of it, is the 265 kW tri-generation, combined cooling, heating, and power. So it's a 265 kW engine that you see right there. That's actually the inside of the Simpson House container that you see right there that was being delivered. It looks smaller in that picture, but it's really nerve-wracking when you're standing across the street watching guys move, I think it's about a 40,000 pound container under electric wires, and thinking what the insurers would probably cringe while they were watching that happen. So it was really incredible the day that was delivered here, and we saw the truck come down the street over there on Monument Ave and come slowly as the fire department closed the road, and they bring this heavy piece of equipment down and then moved it and set it into place. And I think we're going to go see it in just a little bit. So the project also includes the absorption chiller, which is the cooling part of it, as well as the CHP, the engine acting as the lead boiler from the heat recovery portion of it. Paul mentioned we also did a substantial boiler replacement and a couple $100,000 in lighting. So I mean, essentially all those energy conservation measures coming together help reduce the payback period on the project and increase the savings to Paul and Simpson House. All of those things come together in an energy infrastructure project to create reliability, to have reliable power, and as Paul mentioned, needed infrastructure upgrades. It was absolutely imperative to do this new, I think, about $20 million development that Paul was doing. And in order to do so, they needed to upgrade this aging infrastructure, but the budget was just about capped, which is why our friends at Aventus recommend that we talk with Kim Williams and Paul and their CFO to discuss various options for doing an off-balance sheet finance project. Security, obviously having energy security or having your own power on site is a great benefit of the project. The energy efficiency is substantial, and sustainability. While it is a fossil fuels, natural gas-fired project, it does substantially reduce the greenhouse gas emissions when compared to grid power. In the specific case of Simpson House, as well as most of the projects that we structure, it's zero upfront capital cost. I mean, essentially, we're doing at-risk project development to survey the project, do the energy modeling, work with the utilities on what types of projects are available, what types of incentives are available, and then coming up with a project, a system, and a finance package that makes sense. As Paul mentioned, it takes a very long time to get through it all, but with fortitude and persistence, we persevered and got a great project done. It's about a $3.5 million project, which I thought was interesting because Paul was saying they needed about $3.5 million worth of upgrades. And I guess we reduced some of the costs on some of the upgrades that might have had to have happened, but we also were able to increase the size of the project by including obviously CHP and other upgrades like lighting. It's a 20-year energy services agreement with O&M is included, meaning the folks at Centrica take care of the O&M. Paul doesn't have to touch the CHP at all, and his facilities guys take care of O&M on the boilers and the absorption chiller, but we maintain the CHP unit. They didn't have to dip into capital reserves, issue bonds, or borrow money, and freeing up their capital to be able to be used for their new facility addition. And also, it allows them to focus on their core mission, which, as Paul said, back in 2004, they were looking at how to grow this facility to serve their clientele and serve the residents here. So it really took that burden off of them and shifted it over to folks like us and Centrica who deal with these types of projects every day. So the options for them were the different finance structures or the different ways to finance a clean energy project. For a tax-exempt facility like Simpson House, they could have issued bonds through the Philadelphia Industrial Development Authority or through one of the state entities. They could have done a tax-exempt lease or other type of tax-exempt financing through a financial services company or bank. But there are a lot of transaction costs associated with that, and they do have to then carry that on their balance sheet. What we propose to them under this ESA is basically it leaves that up to us for how we're going to do the finance structure using some amount of debt and equity, and they don't have to worry about getting to a finance closing in order to undertake their project. And the other thing too is for a lot of governmental customers and tax-exempt customers, or even commercial and industrial customers that want to specialize in what they do and not energy infrastructure, is it allows us and our investors to utilize the tax benefits, the depreciation, and any other tax incentives, which are a big part of those projects. And basically, we're able to fund those because of the securitized revenue streams or the contracted revenue streams of the energy services agreement payments, as well as the grants and incentives that come into play, and demand response revenue or other types of revenue that are available through demand reduction. I think it's been said, I've certainly said it, Paul said it, and I'm sure Crystal will say the same. And these really require complete collaboration of a lot of different partners, from utility partners like PGW, our good friends from PGW are here, And they really do an excellent job of supporting CHP in Philadelphia, and couldn't be any better partner in assessing the viability of the gas lines, whether any upgrades are required, dealing with us for connection and metering. And they really get it, understand it, and help us get CHP projects done in the city. PECO's Smart Ideas program and Smart On-Site program was a couple $100,000 worth of incentive that were absolutely imperative for making the economics work on the project. And I'll talk grants in a little bit. We also went to the state, but other partners on this, of course, were Energy Rudox, which is now Centrica Business Solutions, our good friends at MCFA, which did the engineering and the construction management, and RAI was the general contractor on the project. And actually, I guess I got there. On the PACFA, that's the Commonwealth Finance Authority, under the Alternative and Clean Energy, we received grant program. We received a $400,000 grant from the Commonwealth. That program is long and murky. It's not particularly easy to get through and takes a long time. But again, persistence and fortitude are absolutely required to get $400,000 from the state under that program, which certainly helped the economics work on the project. Going into the ESA structure, the Energy Services Agreement structure, which is what we do here. I mean, essentially, it's a project where a private owner owns and operates the energy infrastructure and essentially sells kilowatt hours and thermal energy to the host customer. So in this instance, it's structured with the host facility being Simpson House, and then we enter into an energy services agreement and a site license agreement where they say, yes, you can use our concrete pad to put your unit, and the energy services agreement spells out all the terms and conditions for this 20-year agreement, deals with O&M and the other issues. And then the project owner is finance partner Energy Rudox, who they bring the money to the table. Blue Sky Power is the project developer, does all the technical, financial, and legal and regulatory issues, all city and state approvals, grants, and technical information. And then we contract with the EPC contractor for constructing, building, and doing final design on the project. And then the O&M provider can be contractor, manufacturer, or a third party that you hire to do the operation and maintenance of the system. And usually they'll give a performance guarantee or at least lay out some type of guaranteed performance while they're doing the O&M. And then that flows up to the host facility so that they know that their systems are being maintained properly. Going through the EIO process, which is EIO is Energy Infrastructure Operations. That's Blue Sky Power's term for all of these different things we do to bring together the development, financing, and operation of energy infrastructure. So we start with data gathering. I have in there 1 month. It probably takes a lot longer than that. Most of you know, if you're in this industry, just getting some electric bills from a customer seems to be the easiest thing, and for some reason, you can spend 6 months saying, no, I just needed 12 months of bills. And they send you a bill for like the sidewalk repair or something, and you're like, wait, I just need a year worth of bills, and somehow it takes a year. But data gathering should take about a month or so. Generally, we're looking for equipment lists, site plans, MEP drawings, as well as a year's worth of bills. Then we move to the field work and technical analysis, all that work Steve did of crawling the facility, trying to understand where all the connections are, figuring out how to come up with a mechanical and electrical scope for the project. And then moving from there to the conceptual design, scope, and then getting cost estimates. A couple different ways to do cost estimates. Either engineers prepare usually high-level cost estimates and then vet those out a little bit through working with manufacturers and contractors on getting those done. In some cases, we have a contractor who's already involved in the project, and sometimes we go out and get bids for contractors to get best pricing on the project. From there, we move to finance structuring and getting an initial pricing and proposal over to the customer. Generally, that takes the form of a proposal that says, and an MOU that says, we want to do this project for you. We've scoped it out. We think we can do this project under the following parameters. If we enter into this agreement, we'll do even more engineering, more finance structuring, and either we prove what we've said we can do and we move forward, or we find out that it's not possible to move forward with the project due to a finance issue or due to a technical engineering issue, in which case, no harm, no foul. We weren't able to get it done, and we walk away. On the proposal and approval, generally for nonprofits, those are going to boards. For commercial industrial, hopefully those are being made by executives. And then we move to ESA negotiation and financing commitment. Once an energy services agreement is signed, we then generally have worked on the finance structure ahead of time, but we're ready to go to a finance closing after we get an executed ESA. And after it's signed, we do final 100% design and are ready to submit permits. Everything from air permits to construction permits, whether we need any land use approvals or other type of environmental issues we have to address. And in that phase as well is utility interconnection and working with the utilities on getting any required improvements permitted and approved. And then from there, we're ready to start construction. Somehow you're ready to start construction sounds like the easiest part. After you've been through all of that, then you're ready to start construction on a project. Usually on these projects, we're looking at about 6 to 12 months, depending on the complexity, amount of piping, et cetera. All right, a number of these we've hit on already, but just to recap in large part, the benefits of an energy services agreement are going the route of having an entity like us develop and finance a clean energy infrastructure project. Again, is that there's little upfront capital cost for your customers, or if you're a host facility and want to do infrastructure upgrades or sustainable projects, is that we don't come in and ask you to spend a bunch of money. It's a pretty silly business model. I know a lot of professional services firms would not want to go that route, but I'm a recovering lawyer, and after having kept timesheets and billed clients for years, I decided I didn't want to do that anymore. And so we started our business with the premise that we think we can help people, and hopefully we can go in and prove our value by being able to do a project, which leads to us looking at a lot of things that don't work out. But on the other hand, it helps us serve clients like Paul, where we get good projects done, and it was worth the time and effort of us and our partners to get them a great project. Benefits to them, apart from not having to spend a lot of initial capital to get a project done, is budgetary certainty. Paul mentioned sort of going forward in time over having many years worth of predictability on costs for electrical and thermal energy. Under an ESA, for 20 years essentially what your electrical and thermal costs are going to be because it's locked in there. Mentioned on finance structure, monetization of tax benefits, the possibility of off-balance sheet tax treatment. Of course, that's up to accountants, and the GAAP rules, FASB rules are changing. So it might have to be recognized, may not necessarily count towards as a liability, but it has to be recognized as a services contract on financial statements. O&M budget shifting, obviously, with a whole bunch of failing machines and equipment and need for upgrades. Paul was spending a lot on O&M, and a lot of customers are spending a lot on patch and repair year after year because they don't have the capital to upgrade the infrastructure like it needs to be. So shifting that O&M budget, you're taking a lot by just doing new infrastructure, but for having us do the O&M on the CHP and energy equipment is substantial. And allows folks to focus on their core mission of caring for their residents or healing the sick or serving students in the case of our university clients. Efficiency, security, reliability, and sustainability is what we specialize in, and that's what makes these projects work and gets everyone's support. That's all I have.